Hey everybody, welcome back. This is Math 35, College Algebra at College of the Sequoias. Today we're going to look at quadratic equations and different ways to solve them. So this is section 1.4. It's on quadratic equations in one variable. All right, so a quadratic equation, you've seen this formula before. It's the trinomial ax squared plus bx plus c. And we're making it an equation, so it's going to equal 0. And to make it quadratic, a, b, and c are numbers where a does not equal 0. So I'll write that down. I had to clean my lens. It was bothering me a little bit. A, b, and c are real numbers. A does not equal 0. If a equals 0, it's x squared goes away and it's not quadratic anymore. And to solve these equations, to solve quadratic equations, we are going to try to, there's several methods. So the first method we're going to really work with is, this is applying the zero factor property. Okay. Applying the zero factor property. Recall the zero factor property. We've looked at this before. A times b equals 0 means that either a equals 0 or b equals 0. One of those two has to hold. Otherwise, two numbers multiplied together do not equal 0. Okay, so let's just look at an example. We'll start off with a simple one where a equals 1. X squared plus 5x plus 6 equals 0. And when we apply this, what we want to do is factor the trinomial and set each parentheses or each group equal to 0. So a times c is 1 times 6. B equals 5. I need numbers that multiplied as 6 and add up to 5. There's only a couple options for factors of 6. We can do 1 and 6 or 2 and 3. That adds up to 7. That adds up to 5. We want that one. Recall when a equals 1, the coefficient in front of the x squared equals 1. We can jump straight to putting these into parentheses. So that's what I'm going to do. I got x there, I got x there, and the 2 and the 3 get put in right here. Plus 2 plus 3. And now note this method, it requires the right side to equal 0. Or other side, I should say. If you're working on the right side, you want the left side to equal 0. Equals 0. If it doesn't, you solve the equation until you manipulate stuff till it does. So at this point, I have one parentheses times another parentheses equals 0. I can apply the 0 property rule. This is like a times b equals 0. And that means that either a equals 0, x plus 2 equals 0, or b equals 0, x plus 3 equals 0. We subtract 2 from both sides here, and we get x equals -2. Or we subtract 3 from both sides here, and we get x equals -3. So x equals -2 or -3 is our solutions. In solution set notation, we would put -2, -3. All right. Let's see what. All right. Let's start off, do another one. Let's make it a little more complicated, kick it up a notch. I'm going to have 10x squared plus x equals 2. If the one side does not equal 0, get all of the values on one side first. All of the terms on one side first. I'll do that by subtracting 2 from both sides. And I get 10x squared plus x minus 2 equals 0. Now I can factor. All right. So a times c, 10 times -2 is -20. B equals 1. I need values that are close to each other because they got to add to 1. And since it's negative, one of them's positive, one of them's negative. The bigger number is positive because they add to a positive number. So I'll start with big positive numbers. I could do like 20 and -1, 10 and -2. What else is a factor of 5 and 4, 5 and -4. That's it right there. That adds to 1. 5 and -4 add to 1. Since a does not equal 1, we have to do grouping. So I'm going to split that x up into 5x and -4x. Keep writing the equals 0 part. In my experience as a teacher, when I see tests and stuff, a lot of students just start factoring. They don't put the equals 0. They just keep manipulating it. And they forget entirely that they have an equation and they think they're just factoring, and they're not. You're solving for x here. So now we'll do grouping. Put those two together, those together. I know I'm going to have an equals 0 here part. The biggest value that 10 and 5 have in common is the value number 5. And these terms both have an x. So I can pull out an x. If I pull 5x out of 10x squared, I'm left with 2x. And if I divide 5x by 5x, I just have 1. Now, if I do this correctly, that should repeat. I should have that 2x plus 1 in parentheses again. What do I need to multiply 2x by to get -4x? I need a -2. And since I didn't just factor and get the 2x plus 1, I'm going to verify that it actually works. -2 times 2x does give me -4x. -2 times 1 does give me -2. So it did factor correctly that way. Then we have 2x plus 1 on both of them. We can pull that out. That's a common factor between each of those. And that leaves behind a 5x minus 2. We now apply the 0 property, or the 0 property rule. I've got a times b equals 0. A and b. So either a equals 0, 2x plus 1 equals 0, or b equals 0, 5x minus 2 equals 0. In both cases, we're back down to a linear equation, simple equation. We just solve for the variable. I'll subtract 1 from both sides there. I get 2x equals -1. and I'll divide by 2. I get x equals negative 1/2. That's one of my options. If I do this one, I'll add 2 to both sides, and I get 5x equals 2. Rather than dividing by 2, I'm going to do the same operation. I'll multiply by 1/5, just to remind you that this is a valid choice. And I'm left with x equals 1/5 cancel out. 2 over 1 times 1/5 is 2/5. So x equals negative 1/2 or x equals 2/5. Either of those solutions work. My solution set is negative 1/2 and 2/5. And the only thing I really want to emphasize here is remember you can check your work to see if it's correct. You check your work by plugging it in. To the original equation, okay? Plug it in all the way back up there and make sure it works. So check here. If you don't check here, but you check later on, you might have made a mistake between here and here. And it works where you checked because it worked on this thing here, but it doesn't work in the starting one. So if you made a mistake, it'll show if you go back to the very beginning. Okay, so that's one approach for solving quadratic equations. We get everything on one side, factor, and set each factor equal to 0. Another option Option B is like taking roots. And the subcategory of this will be completing the square. I'll show that in a second. Well, let me just give an example. If I've got x squared equals 4, if I take the square root of both sides, what I get, remember the square root of x squared is the absolute value of x. Square root of 4 is 2. When you have the absolute value of x, this ends up being x equals positive 2 or negative 2. So those are two solutions for it. And you'll notice if you plug them in, it works. X squared equals 4. If I plug in 2 squared, that equals 4. If I plug in negative 2 and I square it, that equals 4. So a lot of people you can bypass writing the absolute value sign. If and only if you can remember there is a positive and negative solution. Most people bypass it once they're comfortable with it. But what's really going on is the square root of x squared is the absolute value of x. So most people, once you're comfortable with it, x squared equals 4. Take the square root of both sides and get x equals, and we say plus or minus 2. That's the same thing as saying 2 or negative 2 as options. Okay? This actually works for any number, so x squared equals c. Leads to x equals plus or minus the square root of c. If c is greater than 0, we've got real numbers. And if c is less than 0, we have imaginary numbers. Which, recall, gives us our I. They don't always have to be perfect squares either. For example, x squared equals 29. We take the square root of both sides. X equals plus or minus the square root of 29. 29 is a prime number. It doesn't get any simpler than that. Or if we had something like x squared equals negative 81, we take the square root, x equals plus or minus the square root of negative 81, which is plus or minus I square root of 81. And the square root of 81 is 9. X equals plus or minus 9I. This can be very helpful in other ways as well. So let me show the next example. If I had something like x minus 8 squared equals 24, I could, option A, write this as x minus 8 equals 24. I can multiply that out. And I can gather like terms by subtracting 24 on both sides. X squared, negative 8x and negative 8x is negative 16x. And 64 minus 24 is 40. Then I could try to factor this and solve. You're going to find that this is not a factor-friendly problem. Factoring only works, there are factors, but the factor method, zero product method, works a lot better if the factors are integers. And in this case, it's not. Doesn't work well here. Finding two numbers that multiply to 40 but add the negative 16. Good luck with that. So, option B. I'll rewrite the problem. And we're going to apply the square root approach here. I can take the square root right now. Since the left side is a perfect square, I can do the square root of both sides. The left side, as long as I remember the right side is plus or minus the square root of 24, I don't need the absolute value signs. The left side will be x minus 8. I then add 8 to both sides. X equals 8 plus or minus the square root of 24. This is two answers. X equals 8 plus the square root of 24. And what is the square root of 24 simplified? This is 6 times 4. And I can pull the 4 out. That's going to be x equals 8 plus or minus 2 root 6. So 8 plus 2 root 6, or x equals 8 minus 2 root 6. And these are different values. If you put them into a calculator, find out what they are. 8 plus 2 times the square root of 6. This is x is approximately, if I round, 12.899. And if I do the minus version 1, 8 minus 2 times the square root of 6, I get x is approximately 3.101. So they're two different values. Usually MATLAB wants the answer that has the radical sign in it. That keeps the accuracy. Okay? This answer and this answer, or written as this, or this, is the most accurate answer. As soon as we convert to decimals, I had to round, which means my answer is no longer accurate. It's close. It's really close, depending on how well I round, but it's not accurate. So what if I had started with x squared minus 16x plus 40? What if I had started here? How can I get it to where it looks like that? Let's talk about that. We had, I'm going to rewrite that. We had x minus 8 squared equals 24. That led to x squared minus 16x plus 40 equals 0, which doesn't factor well. How do I go from the right side to the left? Right equation to the left equation. Where it is solvable. This is that these are equal and the arrow goes both ways. This is called completing the square. So I'll show you how to do it, then I'll write down like the terminology for it. Like write it out in words. So let's start off with x squared minus 16x plus 40 equals 0. First thing I'm going to do is move the constant to the right-hand side. I'm going to subtract 40 from both sides. I get x squared minus 16x equals negative 40. Leave some room to work. Then what I'm going to do is I'm going to take this value right here, negative 16. I'm going to divide it by 2 and square it and put that here, and I'm going to add it over here. Negative 16 divided by 2 squared is negative 8 squared, which is 64. I'm going to write plus 64 and plus 64. Okay? This gets me, I now have x squared minus 16x plus 64 equals 24. Notice we've got the 24s on both sides now. If you factor the left side, it has to multiply to 28 times c is 64, b is negative 16. You're going to find the only ones that work are negative 8 and negative 8. Notice negative 8 is that value right there, negative 16 over 2. So you can bypass that approach, bypass the factoring. You already will have the factors. This is called completing the square because this is a square. I can write that as x minus 8 squared equals 24. So, and then do the square root approach like we just did. when I do this in all practicality, as I'm going to do on the next step, I do this, cut it in half, I divide it, I write down what I'm doing, write down negative 16 divided by 2 squared. I show what I'm adding to both sides. And then I literally just take that value and plop it into a square thing, okay? So let me write out what I did in words, then we'll do some more examples. This completing the square method works if A equals 1. So A has to equal 1 for complete the square. It's called completing the square because I took something that was not a perfect square and I made it into a perfect square. Okay? All right, so what did I do? Completing the square. Completing the square. So we want if we're starting off with ax squared plus bx plus c equals 0. Step 1, if a does not equal 1, divide everything by a so that it does equal 1. The x squared term has a coefficient of 1. And you know what? You have to complete the square approach, even if it gets you fractions. That's the complete the square approach. Then, step 2, move the constant to the right-hand side. By subtracting or adding, if it's negative, to both sides. And the constant is either c or if we divide it by a, it's the c over a. Okay? In the last problem, what we did, the constant was, let me pull it back up. The constant was this 40. I moved the 40 over by subtracting. Okay? Then, step 3. Take 1/2 of the x's coefficient or divide by 2 is the other thing. Either multiply by 1/2 or divide by 2 and square it. Add this value to both sides. This is going to be either b, or if we had divided by a, b over a. So if we take 1/2 of this, you either end up with 1/2 b or 1/2 b over a, which is b over 2a. And then you're going to square it. Okay? Whatever this value is, whichever one you use, step 4 is factor the left side into a perfect square. And every single time it should be x plus b over 2a squared. A might be 1, but that's always going to, and b might be negative, but this is always the case that's going to happen. You do not need to memorize this little formula, just memorize the technique. Okay, we're going to do some more examples. Finally, step 5, use square roots to solve. Don't forget the plus or minus. All right. Pause for a second. Absorb that up. All right, so let's look at another example. We've got x squared plus 6x plus 8 equals 0. I'm going to point out, we know we could factor this. We're going to get x plus 2 times x plus 4 equals 0. And if we use the zero product approach, we're going to get x equals -2 or x equals -4. Those will be our answers. Let's do complete the square. Start off, subtract 8 from both sides. X squared plus 6x equals -8. I'm going to take this positive 6, I'm going to divide it by 2, and I'm going to square it. This is 3 squared, which is 9. Add it to both sides. Plus 9 there, plus 9 there. On the left-hand side, I can jump straight to the parentheses. X, and then I'm going to take this value right here, the 3, put it right there, plus 3, equals, the right-hand side is -8 plus 9 is 1. I'm going to now take the square root of both sides. If I make the right side equal plus or minus the square root of that, well, plus or minus the square root of 1 is 1. I have x plus 3 equals plus or minus 1. This gives me two answers. X plus 3 equals 1, or x plus 3 equals -1. You still have to solve. If I subtract 3 from both sides, I get x equals -2. Or if I subtract 3 from both sides here, x equals -4. Notice that's what I had up there. So the factor method and complete the square method will reveal the same answers. You do not leave it. If I had subtracted the 3, I get x equals -3 plus or minus 1. You don't leave it like that. Split it up. X equals -3 plus 1, or x equals -3 minus 1. Okay? Don't stop there. Get two unique answers. The only time they're not unique is if the right side was 0 when you took the square root. Okay? So here you can either subtract the 3 over and then calculate it, or you can split it up into two equations like I did over here and solve for each one there. They both yield the same answers. All right, I want you guys to try. I've got x squared minus 8x plus 15. Oops. X squared minus 8x plus 15 equals 0. go ahead and pause the video and try to solve that. Try doing it, do it both methods, do factoring and do complete the square. All right, I'm going to assume you did. If you factor this, this will factor to x minus 3 and x minus 5 equals 0. I set each of these equal to 0. And I get x equals 3 or x equals 5. That's the factor and zero product method. The other approach, I'm going to, first off, I'll subtract 15 from both sides. And I'm going to leave some space to work. X squared minus 8x equals negative 15. I'm then going to take the negative 8, divide it by 2, and square it. This is negative 4 squared. And if I add that to both sides, I'm adding 16. Negative 4 squared is 16. Having done that, I did the perfect complete the square. Whatever that value is, I drop it right there. It's negative 4, which is negative 8 divided by 2. I'm going to put it right there. The right side is negative 15 plus 16 is 1. Now I can take the square root of both sides. And I get x minus 4 equals plus or minus 1. X equals, if I add 4 to both sides, 4 plus or minus 1. And I split that into two options, x equals 4 plus 1 or x equals 4 minus 1, which gives me x equals 3 or 5 there. And 4 minus 1 is x equals 3. Those are the values I had up there. All right. Let's give you another one to do. X squared minus 10x plus 21 equals 0. Pause it and try to work that out. Well, I'll subtract 21 from both sides. X squared minus 10x equals negative 21. I will take that negative 10 and I will cut it in half and square it. That's negative 5 squared, which means my parentheses is going to be x minus 5 squared. What is negative 5 squared? Negative 5 squared is plus positive 25, so I'll add 25 to both sides. And when we add it to the left, that's how it allows us to complete the square and get that factor. Negative 21 plus 25 is 4. If I take the square root of both sides, I get x minus 5 equals plus or minus the square root of 4 is 2. Add 5 to both sides, I get x equals 5 plus or minus 2. If I do the positive one, x equals 5 plus 2, I get x equals 7. Or I could do x equals 5 minus 2. That gives me x equals 3. Or in solution set notation, 3 and 7. Doesn't always lead to nice values. Try your hand at this one, x squared plus 10x minus 20 equals 0. I'll assume you paused it and did that and worked it out. Hopefully you took the following steps. We're going to add 20 to both sides. And I'll get x squared plus 10x on the left. And on the right side, I get 20. Then I'm going to take the 10, I'm going to divide it by 2. And I'll square it. That is 5 squared. And that's what I'll add to both sides. So plus 25 plus 25. We'll take that and we dump it straight into parentheses. 5 is positive, so we're going to put in plus 5. And 20 plus 25 is 45. Okay. Now that we've got a perfect square on the left, we can take the square root. And I get x plus 5 equals plus or minus the square root of 45. And let's see, 45 is 9 times 5. So I could do square root of 45 is square root of 9 times square root of 5. Square root of 9 is 3. Square root of 5 is 5 is a prime number, so we'll leave it like that. So this is x plus 5 equals plus or minus 3 root 5. I subtract 5 from both sides. And since I got a radical there, I can't combine them. Negative 5 plus or minus 3 root 5. Those are two answers. MATLAB may want you to separate them out. I get x equals negative 5 plus 3 root 5. Or x equals negative 5 minus 3 root 5. Not always pretty. Next one's even worse. And I'll get you started on it, and then I want you to try to do it. Challenging. We're going to start off with 4x squared plus 6x plus 5 equals 0. To start you off, remember you have to get a must equal 1. To make that happen, I'm going to divide everything by a. And I get x squared plus 6/4 x plus 5/4 equals 0. This might be easier to reduce to 3/2. And you want to complete the square here. You will get an imaginary, or you will get a complex solution. So if you pause it and you're working out, it's gonna be ugly. Complex solution with radicals. It's an ugly solution. So just because you get it doesn't mean it's wrong. I recommend don't divide by 2, multiply by 1/2. Okay? That's what I'll do here. I'll assume you paused and worked on it. What I'm going to do is I'll take the 3/2 and I'm going to multiply it by 1/2 and square it. That is 3/4 squared, which is 9/16. That's what I'll add to both sides. This goes in parentheses. So, and I got to move the 5/4 over. Subtract the 5/4. We do that cutting it in half. 1/2 times 3/2 squared is 3/4 squared. If I add that to both sides, it's plus 9/16. This conveniently drops into the thing. You don't have to factor it. Factoring this left side is completely hard the way it is. You've already got it what it breaks down to. It's x plus 3/4 squared. The right side, I need to get a common denominator first. So maybe, what do I need to multiply 4 by to get 16? I need to multiply the bottom by 4, so I'll multiply the top by 4. And this ends up giving me negative 20 over 16 plus 9 over 16 is negative 11 over 16. Told you it was going to get ugly. We'll take the square root of both sides. The left side's simple as it is. The right side is the square plus or minus the square root of negative 11 over 16, which is plus or minus the square root of negative 11 over the square root of 16. On the square root of negative 11, I can make it I root 11 on top. The square root of 16 on bottom is 4. So x plus 3/4 equals plus or minus I times the square root of 11 over 4. Subtract 3/4 from both sides, and there's your answer. X equals negative 3/4 plus or minus. You can have the I on top of the fraction or in front of it. I think if you put the I on top of the fraction, it makes it clear that the 4 is not underneath the radical sign. And it's important to remember this is 2 solutions. Or we could alternatively write, you can put the I afterwards with the fraction like that. It might actually be easier to see it that way. So we either have this as a solution or that is a solution. All right. Doesn't have to be pretty to be correct. Doesn't have to be pretty. It doesn't have to be easy. It doesn't have to be nice or simple to be correct. This problem was more challenging because remember, we started off, A did not equal 1. So you got to divide by A, and that caused the fractions and caused all the fraction parts to show up through all of it, which is the harder part, not necessarily the I. All right. So there is a third final method. It's called quadratic formula. So the third method for solving quadratic equations is using the quadratic formula. And I'm going to show you how it's developed. We will develop it from scratch. we're going to start off with ax squared plus bx plus c equals 0. And to do that, to develop it from scratch, the formula, we're going to complete the square on a, b, and c, using a, b, and c. Okay? So what did we do when we completed the square? We subtracted c from both sides. I get ax squared plus bx equals negative c. I then take the b, I divide it by 2. Yep. Got to divide by a first. And I get x squared plus b over ax equals negative c over a. Now we cut it in half. And the easier way to do that is take the 1/2 and multiply it by b over a and square it. This is b over 2a squared. That's what I'll add to both sides. Since I don't know what the values are, I just got to leave it as it is. So the left-hand side is, I can just take that and drop it in parentheses. X plus b over 2a equals, or squared, equals, I've got negative c over a plus, if I square this, it applies to both things on top and bottom, plus b squared over 4a. Now, if I want to make this one fraction, I can. I got to multiply this by 4 over 4. And if I do, I get x plus b over 2a squared equals negative 4c over 4a plus b squared over 4a. And I'm going to make this one fraction and just say b squared minus 4c. I'm missing something. Oh, this is 4a squared right there. That's the problem. I got to multiply this by 4a on top, 4a on bottom. So this will be 4ac over a squared. I knew it looked wrong. B squared minus 4ac over 4a. Now we take the square root of both sides. I get x plus b over 2a equals plus or minus, I can do the square root on top and bottom separately. Square root of b squared minus 4ac all over the square root of 4a squared. But that bottom part is 2a. If I subtract b over 2a from both sides, I end up with the quadratic formula. We combine it to make one fraction. That's the quadratic formula. It's worth memorizing. And there's a story that'll help you memorize it. So I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's your story, or tale. A negative boy was undecided about going to a radical party. Radical used to be a good term. It didn't mean extreme, it just meant awesome. Going to a radical party. Being such a square, though, he missed out on meeting 4 awesome chicks. The party was over at 2 a.m. That's the story. It's a way to memorize it. A negative boy is negative B. Undecided, he's plus or minus, not sure if he wants to be plus or minus. The radical party is the radical. Being such a square, he was B squared. He missed out on meeting 4 awesome chicks. He lost, minus 4 awesome chicks, 4 AC. And the party was over at 2 a.m., so we'll divide by 2A. I don't know. I heard it. Someone told me it. I liked it. It's worth memorizing. Hell, if you practice generating it from ax squared plus bx plus c, you will completely master this topic. You will completely understand completing this. You'll be pro at completing the square. You'll be a pro at memorizing the quadratic formula. It's definitely well worth it. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That radical, the b squared minus 4ac, this inside is called the discriminant. B squared minus 4ac is the discriminant. And you'll notice we have a couple options that ends up. If b squared minus 4ac equals 0, that entire radical goes away. We don't need the plus or minus anymore. X just equals negative b over 2a. That's option 1. Option 2, if b squared minus 4ac is greater than 0, then this is a positive number, and we're taking the square root of a real number, a positive number, which means x has 2 real answers. They may not be friendly. They may have weird, square root of 67 all over 13. Might be some lame stuff like that, but it's there. And the third option is if b squared minus 4ac is less than 0. It's negative. Then what I'm doing is I'm taking the square root of a negative number, and that's going to lead us to x has 2 complex solutions. Okay. So negative b over 2a, that's one real solution. One real solution. If it's 0, one solution. If it's positive, there's 2 solutions that are real. And if the radical has a negative in it, it's got complex solutions. They actually break it down a little bit more. They also say stuff like you can actually categorize it even more. If b squared minus 4ac, if it's a perfect square, then the radical will go away. You'll take the square root of a perfect square. The radical goes away. We're just left with two real or two rational answers. Not necessarily real. It could be negative. No radicals. Or if b squared minus 4ac is not a perfect square, you're going to have radicals left over because you can't get rid of them. It makes these irrational answers or solutions. All right. So let's see how this works. Example. And I'm going to rewrite down the formula on this page because I'm fairly sure not everyone's got it memorized. And we are going to start off with, we're going to have x squared plus 6x equals 3. To use the quadratic formula, the right side has to equal 0, or one side has to equal 0. For the quadratic formula. Now, it takes some work to memorize, but flashcard it. Flashcard, flashcard, flashcard. So I do not have it equal to 0 right now. So what I'm going to do is I'm going to subtract 3 from both sides. And if I do, I get x squared plus 6x minus 3 equals 0. So that value right there is missing, which means a equals 1. This value right here is my b, that's 6. And that value right there is my c, it's negative 3. I'm going to take those, plug them in there, and this is what I get. X equals negative 6 plus or minus the square root. I've got 6 squared minus 4 times a is 1 times c is negative 3. And this is all divided by 2a, 2 times 1. So replace a, b, and c in the quadratic formula with the coefficients from that thing. And now it just takes, this is just some operations. X equals, well, I don't need the parentheses there, negative 6 plus or minus. 6 squared is 36. And then I've got minus 4 times 1 is negative 4. And the negative 4 times negative 3 is plus 12. The bottom is 2 times 1. So I get x equals negative 6 plus or minus the square root of 48 over 2. Let's see, 48 is 6 times 8. This is 2 times 3, and that's 2, 2, and 2. 48 is 2 to the 4th times 3, or 4 squared times 3. So x equals negative 6 plus or minus. I can pull out the 4 squared and make it 4 on the outside, root 3 all over 2. And this is where you'll probably break it up into 2 answers. X equals -6 divided by 2. Well, not 2 answers. We're going to break up the fraction. -6 divided by 2 is -3. And then I've got plus or minus 4 over 2 is 2 root 3. And you're left with 2 answers. Okay. Let me give you another one. I want you guys to try this. 4x squared equals 3x minus 5. And go for it. Conveniently, a does not have to equal 1 in the quadratic formula. Pause it, try to work that out, see what you get. All right. Make sure you subtract the 3x plus and add 5 to both sides. You get 4x squared minus 3x plus 5 equals 0. So a equals 4, b equals -3, c equals 5. I'm just rewriting down the formula, -b plus or minus the square root of b squared minus 4ac. All of that divided by 2a. And I'll plug in what I have. X equals, I'm just putting in some parentheses. And I'm replacing a, b, and c with parentheses, and I'll fill them in now. B is -3, that goes there, and that goes there. A is 4, that goes here, and that goes here. And c equals 5. Now we just gotta go slow. Don't rush it. Plugging stuff in is not the hard part. If you memorize the formula, it's not hard. It's easy to mess up though. Negative and negative make it a +3. Then I have plus or minus the square root. -3 squared is +9. And then 4 times 4 times 5. You might do 4 times 4 first, but check this out. 4 times 4 times 5. I think it's easier to do the 4 times 5 first. It's 4 times 20, because 4 times 20 is 80. That's like having 4 $20 bills. That's easier than doing 16 times 5. So I'm going to have 9 minus 80 in there. The bottom is 2 times 4 is 8. And 9 minus 80 is -71. So I have x equals 3/8. I can break it up, plus or minus the square root of -71 over 8. And I don't want to leave it with a negative in the radical. X equals 3/8 plus or minus, I can do square root of 71 over 8i. Or we could have x equals 3/8 plus or minus I square root of 71 over 8. Either one works. And remember, each of these is 2 solutions. The plus or minus, you break up into 2 values. Only a little bit more. We can actually apply this to something that makes a perfect cube. Or not perfect cube, but has cubes in it. So check this out. X cubed minus 125 equals 0. This is like x cubed minus 5 cubed equals 0. Well, remember, a cubed minus b cubed, we did this in the review section, a minus b, a squared plus ab plus b squared. So I can apply that here. I have x minus 5, that's my a minus b. Well, I'll fill it in up here, x minus 5. And then I've got x squared plus x times 5 plus 5 squared right there. When I put it down here, I'm going to clean that up. I've got x squared plus x times 5 is 5x, and plus 5 squared is plus 25. It still equals 0. Okay? Zero product rule. I've got two things multiplied to make 0. One of them has to equal 0. Either x minus 5 equals 0 or x squared plus 5x plus 25 equals 0. We add 5 to both sides here, we get x equals 5. Or, blue pin's done, toss it, grab a fresh one. Or, this does not factor well, so I'm going to use the quadratic formula. A equals 1, B equals 5, C equals 25. So I've got negative 5, that's negative b, plus or minus b squared is 5 squared minus 4 times a times c, all over 2 times a. Well, not pretty. 5 squared is 25, and 4 times 1 times 25 is 100. The bottom's 2. So that's negative 75 on the inside. And negative 75 is negative 1 times 25 times 3. Negative 5 plus or minus the square root of negative 1 times the square root of 25 times the square root of 3. I'm just breaking up the square root of negative 75 up into 3 parts. That's all over 2. And I still have x equals 5 is an answer, or x equals negative 5 halves. Square root of negative 1 is I, and the square root of 25 is 5. So plus or minus 5i root 3 over 2. Or you can, you want to put the I on the outside. Do I times 5 root 3 over 2. Or the I could go at the end or at the end there. 3 solutions here though, right? 1 solution here, 2 solutions here, total of 3 solutions. Remember me telling you the exponent led to the number of solutions? That's the case here. Exponent is 3, 3 solutions. They're not all real solutions. I have 2 complex solutions and 1 real solution. So let me give you a fun problem. Tribute to Donato. He's one of my former students. He's our supplemental instructor or student instructor now. Let's do a word problem. The human cannonball denial is launched from the ground straight upwards with an initial velocity of 73.5 meters per second. The cannon is quickly removed and placed with a pool of water. Cannon is moved quickly, revealing a pool of water underneath. Cool. Neglecting air resistance, so we're going to pretend there's no friction. The formula for his height above ground is height at time t is negative 4.9 t squared plus 73.5 t, where t is time in seconds. When is he 100 meters above the ground? When he's, that's the question. So I'll pause, let you write that down. Well, when he's 100 meters above the ground, that means his height at time t is 100 meters. This is all in meters. And we can set that equal to negative 4.9 t squared plus 73.5 t. And what we're going to do is we're going to solve. I'm going to move to the left by adding or subtracting. If I do, you'll see I get 4.9 t squared, it's positive now, minus 73.5 t plus 100 equals 0. So using the quadratic formula, t equals, well, negative b is positive, so this is my a, b, and c. Negative b is going to be positive 73.5. And then I've got plus or minus b squared is negative 73.5 squared. A is 4.9 and C is 100. A goes down here is 4.9. If I do that, I get T equals 73.5 plus or minus the square root of 3,442.25, all divided by 9.8. And if you throw that into a calculator and you do the plus or minus versions, that cleans up to, we've got 73.5 plus or minus. If we round it, it's approximately 58.7, all divided by 9.8. T is approximately 13.5 seconds, or 1.5 seconds. Try working that out and see if you get that. This is kind of like what shows up in 1.5. 1.5 is on word problems, and they will do different word problems. You might, if you're interested in it, check out the multimedia library section. And that's it for this lection. Peace. Pause the video. I hope everyone has a great day.